Hello again YouTube. Since I made my smart home tour video, I've been literally inundated with a comment asking me about how I made my smart home air fresheners. So I thought I'd have a go at making a step-by-step video tutorial. I hope you find it useful and let me know what you want to see next. This is the device in question. It may look standard, but this one's Zigbee and is integrated into Home Assistant. Yet it can still be triggered manually by pressing the button on the top. For this, I've used a circuit board and touch sensing pad from a Zigbee Fingerbot. A Fingerbot is a device that can press the button or flip a switch on an otherwise dumb device. And as it turns out, its brain is a perfect replacement for the timer circuitry in one of these air freshener dispensers. And its touch sensing pad means it can retain manual control. As with all my other smart home projects, I try to retain manual controls and avoid external wiring or otherwise ruining the appearance. I'm particularly pleased with the fact I'm even using the same two AA batteries in the same compartment for power.
Why?
Why did I do this? I love automating things. I don't need it to spray 40 plus times a day. I don't need it to spray when we're not home. I don't need it to spray for brief visits. But most importantly, I don't want to be showered with air freshener whilst I'm minding my own business. The air freshener dispenser I'm using for this project is this one from Amazon, which costs just £10 English. The Fingerbot is around £14 from AliExpress. There are Bluetooth or rechargeable versions, but that's not what I'm using for this project. You might be asking, why not use an ESP32? Well, the simple answer is battery life. An ESP32 would last weeks on AA batteries, not months. And why didn't I build my own custom Zigbee device? Well, it's because, frankly, I just don't know where to start. Anyway, let's get started.
No, God! No, God, please, no! No!
Let's gather together the bits we need, starting with the air freshener dispenser. Here's our Zigbee Fingerbot. A couple of bits of heat shrink, some wire snips, a craft knife, some spare extra wire, 26 or 28 gauge is ideal, a flathead and a Phillips screwdriver, wire strippers, a soldering iron, a lighter to heat the heat shrink, some solder or solder for any Americans watching, optionally some flux to help our solder go where we want it to go, and finally a hot glue gun. Here's our air freshener dispenser. On the back you'll find a 3-position switch. The 3 positions correspond to low, medium and high frequency. The bottle will last about 70 days on low, 35 to 45 on medium and 20 to 30 days on high. Pressing this button on top results in an extra on-demand manual spray. The air freshener bottle is behind this door and simply slides in and out like so. Here I'm just popping in a couple of batteries to test it out and show you how it works. I'm just using any old batteries for now, though in hindsight I think these ones must have been pretty flat. I forgot about the ones supplied with the dispenser. Hopefully you can see what's happening. When I press the button, or every X minutes depending on the low, medium, high setting, the lever at the top presses down onto the squirter doodad on top of the spray bottle. Yeah, these batteries have definitely seen better days. Don't worry, I'll pop some fresh ones in there when I'm done with the conversion. I'm hoping it along a bit at the moment with my thumb here. Yeah, here we go. You can see there what should be happening. Okay, let's take a look at the Fingerbot. The battery door just pops off the back like so. As this is a factory fresh device, as soon as we remove this pull tab it will start looking for a Zigbee network to join, as indicated by this flashing LED. So let's hit permit join in Zigbee to MQTT, or the equivalent in ZHA. And a few moments later, it's discovered. And a few moments after that, the interview is complete, Z2M knows what it is and we can configure it. And sure enough, the LED on the Fingerbot stops flashing to let us know it's paired. Let's pop it back together for now so we can see how it works. If we press the touch sensitive button on top, the little finger moves up and down once. That behaviour can be changed in Z2M or presumably ZHA, but click is what we want here. We want it to go down and up once per state change, so that's fine. You'll notice that Home Assistant considers this to be a switch, and that turning on or off that switch results in a down and up movement. That's also fine, we'll deal with that later. Hopefully this side-by-side demonstration shows why this conversion is so easy. Both devices perform a very similar linear up and down movement when requested, except of course, one is smart and one is not. Okay, time to start disassembly. The first thing we need to do is remove the large push button. We need to pinch these two tabs with holes so that they can pass the plastic pins on either side and allow the button to unclip out of the way like so. Eventually I gave up trying to use the craft knife for this and went with the screwdriver for better leverage. We need to get the screwdriver into this gap here on either side, whilst applying force to try to lift the button up and off.
One eternity later.
There we go. With that out of the way, we can get to the screws we need to get to take this apart. There are 3 of them, here, here, and here. Don't forget this third one, that would be silly. Be sure to use an appropriately sized Phillips screwdriver too, not like this one. That's more like it. Just to give you a better view of where the screws are, well, 2 of them anyway. Don't forget about this one. Please forgive my mower beeping in the background. It's probably trying to eat another swing ball bat. We all know how this is going to go, don't we? Penny dropping in 3, 2, 1. Let's take that third screw out, shall we? What a good idea! There we go, much easier. Quelle surprise! This little thing here is used to press on the push button on the original PCB when you press down on top of the unit. Don't throw this away, we're going to use part of it to stabilise the Fingerbot PCB in a moment. Yeah, it went in here something like this. Ooh, and out pops that pesky third screw. Let's keep that safe. The original PCB just slides out, taking the positive and negative battery terminals along with it. And now we can disconnect the Air Wick PCB from the motor. Okay, Air Wick disassembly done, let's turn our attention to the Fingerbot. First things first, let's take off the battery cover. And remove the battery. You can keep the battery in your random crap drawer or dispose of it safely. With the battery removed, you get a nice clear view of the battery terminals. They're just a push fit into the Fingerbot case, no fixings or glue. Using the craft knife, I'm going to slide these terminals out of the Fingerbot case. There goes one. And there goes the other. The PCB is just held in with some sticky pads on either side, so it's really easy to remove. Just like so. Don't pull it too far though, so as not to strain the motor or touchpad wires. Now I'm just gently teasing the copper pad from the underside of the touch sensitive button using my craft knife, being careful not to cut or tear it. And there we go, it's now free from the case as well. Here you can see that the last thing tying the PCB to the Fingerbot case is the positive and negative motor wire. Now using my small Phillips screwdriver, I'm going to remove the 4 screws inside the Fingerbot. I'm doing this so that I can find the end of the motor wires and snip them as close to the motor as possible, which will make soldering them easier. Now we can strip them off with as much length as possible. There we go, one liberated Fingerbot PCB with everything we need for our conversion. You can see we have 5 wires here. We have one connected with 3 wires, yellow, black and red, button, ground and 3 volt respectively. And we have another connected with the positive and negative motor wires. Okay, back to the air freshener dispenser. Of course, the battery compartment is currently missing the positive and negative terminals. They were removed with the original PCB. But that's fine, that was no accident. What we're going to do is borrow the negative terminal from the Air Wick PCB. Because this one will slide neatly into place. And we know it will hold our AA battery securely. Unlike the terminal from the Fingerbot PCB, which, as you can see, just doesn't have a large enough spring. So I'm just going to bend the terminal back and forth. I want the terminal along with a little tab onto which I'm going to solder the negative battery wire for the Fingerbot. I'm just going to keep bending it back and forth until it eventually lets go. There we go, that's just what we need. And that just slides straight back into the Air Wick battery compartment, back to where it came from originally. Now I'm going to use my soldering iron to remove the Fingerbot's existing negative battery terminal from the end of the negative wire on the 3-pin connector. There we go. And now, whilst I have the soldering iron ready to go, I'm going to carefully melt the plastic around the negative battery terminal to hold it in place and stop it from falling out. It might be better to use glue, as I'm sure these delicious plastic fumes can't be good for you. Okay, looking good. Earlier Fingerbots used a monolithic PCB with the Zigbee SoC all on one board, but these newer ones have a Zigbee mezzanine board sticking out at 90 degrees. This makes it slightly more awkward to fit into the Air Wick, but we'll cope. I want to position the board such that the reset button and LED can be accessed or viewed through the hole at the back where the low, medium and high switch used to be. Now I'm pressing the positive battery terminal from the Fingerbot into the slot where the Air Wick's positive battery terminal used to go. It's a tight fit, but that's a good thing, and with a bit of persuasion it will slide into place. Pressing the corners down with the screwdriver helps. And there we go, 2 terminals looking good. Okay, let's position the Fingerbot's negative battery wire and solder it onto the negative battery terminal from the Air Wick PCB. I'm hoping that a little dab of flux will help. I'm not very good at soldering though, so take that with a pinch of salt. Looks okay to me. Okay, now we need to snip off the connector from the Air Wick motor so that we can solder on the one from the Fingerbot. And now let's strip the ends of the motor wires so we have something to solder. 5 or 6 millimeters should do. Now let's prepare a couple of small pieces of heat shrink, about 15mm in length. And let's slip them over the red and black wires from the Fingerbot motor connector. I'm going to solder the red or positive motor wire first, so first of all I want to get everything in a convenient position. I'm just using a bit of cardboard here to protect my desk from the heat of the soldering iron. And in the absence of anything more fancy, I'm just using a bit of tape to hold the wires in roughly the right place. Little dab of flux. That'll do. Time for the negative battery wire, and again a bit of tape to hold things in place. Now I'm going to desolder the touchpad wire from the copper touchpad itself, so I can also extend that. Here's where the assorted spare wire comes in. Here I am choosing some matching yellow wire to extend the touchpad wire. Let's now strip the ends ready for soldering. Now it's time to solder one end of our new bit of yellow wire to the copper touchpad. Okay, here we have our copper pad ready to be stuck to the top of the Air Wick. Let's get it connected back to the yellow wire from the Fingerbot connector. Last little bit of heat shrink. Okay, soldering done. Now we can slide the heat shrink over our joins. Okay, let's shrink it. Not too much, we don't want to melt or burn anything. My second error was not reconnecting the motor connector to the PCB before I continued. That will also come back to bite me later on. Otherwise, that's the soldering completed. Now I'm trying to work out how I'm going to position the Fingerbot PCB and what I need to cut in order to achieve that. Again, I want the button and LED to be positioned where the switch hole is. I've worked out where I need to cut a small triangle out of one of the support ribs inside the Air Wick, so I'm using my soldering iron to do that. Okay, I think we're looking good. Time to heat up the glue gun. Before we start sticking, we need to make sure that the copper touchpad and wire is fed through this opening at the top of the Air Wick device. Now we can stick the copper pad to the thinnest part of the Air Wick button, roughly in the middle. The adhesive that's already on the copper pad is fine for this task. About here should do the trick. And I'm just going to take the blunt plastic handle end of my craft knife here and use that to simultaneously flatten and stick the pad to the back of the button. Make sure both connectors are connected to the Fingerbot PCB at this point. I forgot. Okay, let's get the board roughly where we want it. I'm going to apply hot glue to this pre-trimmed area and stick the board directly onto it. Now I'm holding it in place until the glue hardens. And I'm going to take a piece of this button actuator, which is otherwise surplus to requirements, and I'm going to make a stand to put between the board and the Air Wick body to further support the PCB. Let's trim off the arms. Quick test fit to estimate the length required. Minor ajustement. A dab of hot glue on both ends. And I'm going to tuck it in behind the PCB, stuck to both it and the inside of the Air Wick. With that bit done, it's time for me to realise I should have connected the motor before securing the PCB in the right place. So let me speed this part up as I fix that mistake. Okay, now we can begin reassembly, starting with tucking in these wires. Now let's get the door hinge back in place. It doesn't snap in place, it's just captive when you reinstall the back cover. Now let's replace the back cover. time for some screws, not forgetting number 3 this time. The button can now be put back on top. And that's it reassembled. Let's pop in some batteries and give it a test. Looking good. Let's pop in the spray bottle. Look at that, to the untrained eye it looks exactly the same as it did before. Okay, these batteries are toast, but it's working. Let's jump into Home Assistant and set up some magic. The first thing I want to do is rename the device in Zigbee to MQTT, or if you're using ZHA, I suspect you'll want to do the same. For the purposes of this video, we're going to pretend that my cabin, i.e. my office, is a bathroom. Next, I'm going to create some helpers, and the first one is a button helper I'm going to expose to my voice assistant. Now I want to create an input boolean helper, basically an on-off switch, to enable or disable automatic spraying. We're going to use the state of this helper as a condition in our automation that actually fires the spray. For my final helper, I want a counter that will increment each time air freshener is deployed, so I know how much I'm using. With that done, here are three helpers: the counter, the input boolean toggle switch, and the button for exposing to our voice assistant. Next we need some automations. We could do it all with one single automation, but I'm keeping things simple for now. This first automation is just going to increment our counter. We're going to start with a new blank automation, and our trigger is going to be when the Fingerbot, which Home Assistant sees as a switch, is toggled on or off. So I'm creating two triggers, one for when the state changes from on to off, and another for the other way around. For my action, I'm going to select counter, increment counter, and I'm going to choose my Air Wick spray counter helper. Let's call this automation Increment Air Wick Counter when sprayed. Next, let's create the automation that will enable the automatic spray boolean if our room has been occupied for X number of minutes. I'm using the cabin motion sensor here as that's where I'm sat and that's where my air freshener is currently located. Ideally you'd use a presence sensor, not a motion sensor, and indeed that's what I'm using in my bathrooms. Otherwise you'll get sprayed if you sit still. So I've selected my cabin motion sensor occupancy entity and I'm setting that to trigger if occupancy is detected for 2 minutes. And for my action, I'm just going to turn on my cabin auto spray input boolean. I'm not triggering the spray itself with this automation. Again, I'm just entering any old name that's going to let me know roughly what this automation does. The last automation is the one that's going to actually trigger the spraying. This time we're going to create a couple of triggers and assign each one its own trigger ID. The first trigger is when cabin occupancy is clear for 1 minute. We're pretending this is a bathroom, remember? For the trigger ID, I'm using cabin cleared. The next trigger is when the input button helper spray air freshener is pressed. I'm not going to bother specifying a to or from state, we don't need to. And I'm adding in the trigger ID of button pressed. For the action, I'm going to add a choose block so we can set different actions and conditions depending on what triggered the automation. So let's start with option 1. I'm using 2 conditions here. The first is that it was triggered by cabin cleared. The second condition is that the cabin auto spray input boolean is turned on. I want option 1 to perform 2 actions. The first is to toggle the Fingerbot switch. You'll remember we renamed the Fingerbot to Air Wick. And the second action is to disable the cabin auto spray input boolean, effectively resetting it until the next visit. Now we add the second option, and this is going to fire if it was triggered by button pressed. And this option is just going to perform a toggle of our Air Wick switch, which will result in 1 down-up press of the spray bottle. Let's save this automation and give it a name. And when we're done with our automations, we should have 3. One that increments the counter, one that deploys air freshener when the cabin is empty, and another that enables the automatic spray when the cabin is occupied for however long we want. Time to add our new device to our dashboard. I want 3 things to be on display. The first is a button card. For the entity, I'm going to choose our cabin autospray input boolean. That way the icon colour will reflect when autospray is enabled. However, I don't want the button to toggle the input boolean, instead I want the button to deploy air freshener when pressed. So I'm changing the interaction to perform the same toggle action on the Air Wick / Fingerbot switch. Next, I want an entities card. And I'm going to remove the default entities here and add in the Air Wick spray counter we made earlier. And the status of the cabin occupancy sensor. Now watch what happens when the cabin is occupied for 2 minutes. Autospray is enabled, and a minute after leaving the cabin, air freshener is dispensed and the counter is incremented by 1. Pressing the spray button on the dashboard is working nicely, and also increments the counter. The same goes for the manual spray button on top. If we look at the stats and Home Assistant for the one of these I have in my downstairs WC, keep in mind we're a family of 4 and our house has a downstairs WC and upstairs bathroom, it sprays about 6 or 7 times a day, which works out about 2,350 times a year. A single bottle of air freshener has lasted about a year, and the battery's about 6 months. The batteries in the one in our main bathroom have lasted about a year. That one sprays about twice a day and the bottle will last about 3 years. However, that one won't spray if we're showering or brushing teeth. That's quite a significant difference to the claimed 70 days you're meant to get, and that's on the most frugal setting. So by spending £15 over the cost of the dispenser itself, I'm breaking even in under 6 months. And that's based on the one downstairs, which is working harder than the one up. And I'm basing that on how infrequently I now need to buy refills. So there we go, we've successfully converted this Air Wick air freshener dispenser into a smart home device, without losing any functionality, changing its outward appearance or requiring any kind of external power source. But now it's automated, it's remote controlled, it's voice controlled. Spray the cabin. And it's keeping the cabin smelling lovely. So that's about it for this video. I hope it's inspired you to either recreate this project or produce something like it. Either way, I'd really appreciate a like and or subscribe if you found it interesting.